Hello everyone. Today I will be solving question 643, and the question is you are given an integer array nums consisting of n elements and an integer k. Find a contiguous subarray whose length is equal to k that has the maximum average value and return this value. Any answer with calculation error less than 10 powered by -5 will be accepted. We have two examples here. The first one is a array with length of 6 and the size of the window is 4. So let's go through more detail of this question. Here is the first example with a window size that is constant and equal to 3, and the question asks us to find the maximum average of all of the sliding window in our array. So the window size is 3. It means that we can consider the average of this, or average of this one, or this one, or this one, or this one. So we can see that we have to keep track of all of the average in our array, and at each time we have to find the average of the current sliding window that we are working. So at the first step, we can find the average of the first window that we have here, that is 3, and our maximum also will be 3. And then in the next window size, our current average is 2, and we compare our current average with the maximum average. If the current average is greater than the maximum average, we update the maximum average, and here 2 is less than 3, so we have the maximum average as 3. And in the next one, the current average is 4, and 4 is greater than 3, we update that to 4, and etc. So the way that we can move forward, we can use 2 pointer, left pointer and a right pointer here. We set the left pointer to 0, the right pointer to the length of our window size -1, since we start from 0. And then, since our window size is constant, we should increase the left pointer and right pointer at the same time. We cannot only increase the right pointer to here and don't change the left pointer here, since in this scenario the window size increases to 4. Or we cannot change this left pointer and keep the right pointer at the previous position, since in this scenario the window size is 2. So at each step of our solution, we have to increase our left pointer and right pointer at the same time to keep the window size constant. Okay, so the left pointer to 0, right pointer to this one, and our current average is 3. The maximum average is also 3. So then we increase the left pointer by 1, right pointer by 1, and then you can see at the second window the current average is 2, the maximum average is 3, which is related to the previous window. And then we increase left pointer again, right pointer, we can see that our current average is 4. Since 4 is greater than 3, we update the maximum average, and then we move our left and right pointer to right. Here we can see that current average is 8. Since 8 is greater than 4, we update our max average to 4, and then the current average is 7, and since 7 is less than 8, we keep the 8 as the maximum average. Okay, so this is the overall approach here, but how we can calculate the average at each step. So for the first solution, we can find the summation of the window size each time. Okay, for the first one, we have 1 plus 12 minus 14 minus 4, which is 9. So we have to do 1 plus 12 minus 4 divided by 3. For the next one, we have 12 minus 4 minus 2 divided by 3. For the next one, we have minus 4 minus 2 plus 18 divided by 3, and etc. So in this way, we are moving our left pointer and right pointer to the end of the array, so we have a time complexity of O of n, and then in our loop we have to find the summation of the window size. So at each time that we are moving our pointer, we have to find this summation, okay? And this summation will be O of k, O of the length of our window size. So overall, with this approach, the time complexity will be O of n times k, and it's not the best solution that we have. So we can see in the coding part, we will solve the question with this approach, and we will see what's happened there. And for this solution, the space complexity will be O of 1, since we don't save anything in any extra space. But we can improve this by a very simple approach. We find the summation of the first window, which is here is 1 plus 12 minus 4, and we have this, okay, which is 9. When we are moving to the next window size, or left is here or right is here, what will happen? We can see that at each time we lose the value at the left, at the previous left, and we will add the value at the current right. Okay, since our right is here, the previous left is here, the current left is here. Okay, so let's to clean this one and only consider that we have this window. Okay, we can see that we lose this number, we add this number. So if we decrease this number, it will be 9, we lose 1, we add 2, which is 6. So we can see that the summation of this window size is 6. Okay, and then when we move our pointer to the next window size, next window, we have this. Okay, so again, we lose this number, we add this number. That is 6 minus 12 plus 18, which is 12. And then by having these numbers, we can divide all of this and find the average at each step. So okay, so at this scenario, we can see that we only move one time through our array, and at each time we only do some operation regarding to decreasing the current sum by one number and increasing the current sum by another number. So in this scenario, our time complexity will be O of n, since we only move through array one time, and at each time we have some constant operation. So overall, the time complexity is O of n, which n is the length of our array, and the space complexity will be O of 1. Okay, so that's it. Let's go to the next window size. Here our current sum is, so let's to write it as okay, here the current sum is 9. Okay, and then we move to this, and we will do 9 minus 1 minus 2, that is 6, and 6 divided by 3 is 2. And for the next one, we have our summation will be 6 minus 12 minus plus 18, which is 12. 12 divided by 3 is 4. And then here we have 12 minus 4 plus 8, which is 24, divided by 3 is 8. And here we have, which is 24 minus minus 2, which is plus 2, minus 5, which is 21, divided by 3 is 7. Okay, and that's it. Let's go to write the code for this question. I write the code for the two solutions that I provided. First of all, we check the length of our array, and maybe our array is empty and the k is a value greater than 0. So at the first step, we check the length of our array. If the length of our array is less than or equal to the k, we return the summation of the nums divided by k. If not, we set two pointer left at 0 and right at k, and then we define a variable max average as sum of the nums from left until the right. And we know that in Python we don't read this number at the index right, divided by k of the max. We set a variable max average, which is the average of the first window that we have, and then we move our left pointer by 1 and our right pointer by 1 at each step. So we can use a while loop or a for loop here to move our right pointer, and since we calculate the average at the first window, then we move our right pointer from k plus 1 until the last value in our array. The reason that I add 1 here, since I want to read the value from the left pointer until the right pointer, and as I said, in Python we don't read the value at the last index in array slicing. So here we calculate the current average as sum of the nums from left until the right divided by k, and at each step we calculate the max average and current average. And don't forget to add 1 to the left at each step, and by end of this we can return max average here. Okay, so here is the solution, and we can see that we cannot submit this. The reason is that time limit exceeded. The reason for this is, since we are, let's analyze the time complexity here. Since at each step we move our right pointer from the first part of the array until the last index, so we have one loop of O of n, which n is the length of the array, and we do some calculation here. This is a summation of nums from left until the right. So we have one operation here that is O of k, since slicing this takes O of k. So the time complexity of this solution is O of n times k, which n is the length of the array and k is the size of the window. So for this reason we cannot submit this, and here the space complexity is O of 1, since we don't have any extra space here. So what we can do to remove this, to improve this solution, for the second solution, again we set our left pointer to 0, right pointer to k, and then at the first step we calculate the summation at a window, which is nums from left until the right, and then we can calculate the maximum of average variable here, and we divide current summation by k, and then we can move our right pointer by a for loop or a while loop here. So I use a for loop to be consistent with the previous solution, and we will change our right pointer from k until the last index that we have. In the previous solution we add 1 here and 1 here, but here we don't need that, since we don't want to use an approach here to slicing the window. The intuition behind that is that at each time we decrease the value at the left pointer from current sum and add the value at the right pointer to our current sum. So at each time our current sum change by the value at right pointer and the value at left pointer. So I think that it's clear, as we already explained this in our visualization. And so here the current sum is this, the current average is current sum divided by k, and at each time we calculate the max average and current average, and by end of that don't forget to add 1 to the left pointer, and by end of this loop we should return max average. Okay, so we can see that this works. And about the time complexity and space complexity, for the time complexity we have one for loop which is O of n, and all of this operation is O of 1. So we can see that with this simple approach, our time complexity decreases from O of n times k to O of n, and n is the length of the array. And for the space complexity is O of 1, since we didn't save any data, we didn't use any extra space here, so the space complexity is O of 1.